Hello everyone, welcome back. Myself Sujit Sali, lecturer in Mechanical Engineering Department, Jain Polytechnic, Belgaum. So in previous video we have seen the introduction to thermodynamic cycle. So what do you mean by the reversible and irreversible cycles and some assumptions. So in this video we'll go through two types of cycles. We'll just cover two types of cycles. Those are Carnot cycle and Otto cycle. So let's get through to the first type of cycle, that is Carnot cycle. So Carnot cycle, it is a theoretical cycle, thermodynamic cycle, which was proposed by a French physicist, that is Sadi Carnot, in 1824. So it is actually a theoretical cycle, so it doesn't have any real life application. It was proposed by the physicist Sadi Carnot, hence we call it as a Carnot cycle. So what actually we'll be learning in these cycles is nothing but whatever the processes are there. For example, if you consider a piston and cylinder arrangement, so when a gas is heated, so in that piston cylinder we will be using a gas. So when that gas is heated, so there will be some expansion processes, some compression processes. So when we combine the different types of processes that is happening during that whole cycle, so those processes are combined one by one to form a cycle. Okay, so in this we'll be seeing how actually a Carnot cycle was proposed, so what is its application, and how actually its explanation. We'll see the main thing is here is the explanation of Carnot cycle. So let's go through what is this Carnot cycle. So here you can see there are two types of diagrams. Okay, the first one is PV diagram and the second one is TS diagram. Okay, so PV is nothing but pressure and volume, and TS is nothing but temperature and this entropy. Yes, we call it as an entropy. So here this diagram shows four processes which are combined to form a cycle. So same way on the right side you have TS diagram, that this chart or what we call as TS diagram shows us the temperature. Okay, so at what state the temperature is maximum and at what state the temperature is minimum. And on PV diagram will be showing what are the different types of processes. So how this actually this what we call PV and TS diagrams are formed, we'll be seeing using this piston and cylinder arrangement. Now consider you have a cylinder. Okay, the cylinder walls are totally adiabatic, means no heat can be transferred through it, inside through this wall, through these walls. Okay, so here inside that you have a piston, okay, which is moving freely inside this cylinder. So here you will be having a system, or what here will be having a gas. Okay, so now here we will be using two types of bodies, that is H we call it as hot body and S we call it as a sink or cold body. And here this C, it is nothing but what we call it as a diathermic material. Okay, so heat can be passed through this diathermic material, heat cannot be passed through this adiabatic material, heat can be passed through this diametric material. So now what are these processes, we'll see them one by one. Okay, so the first process, that is process 1 to 2, we call it as isothermal expansion. So how that happens, so now initially gas will be here. So once the gas is filled in this inside cylinder, what we'll do is we'll place this diathermic cover just at the bottom of the cylinder. Okay, and when once we place it, what we do, we'll bring this hot body closer to this. So now what happens, the hot body supplies the heat through this diathermic into the gas. So what happens, the gas absorbs the heat from the hot body and it starts expanding. Okay, and it starts expanding, and whatever the energy it absorbs, that heat energy, so that energy is transmitted to this piston. Okay, when the gas expands, the piston starts moving. So during that process is what we get this first one, that is isothermal expansion, means the heat is added to the gas and the gas starts expanding. So that's why we call this process as isothermal expansion. So during this isothermal expansion, the pressure is starts reducing and the volume starts increasing. The pressure reduces, okay, simultaneously the volume increases. So next, after the heat is supplied, what happened, this diathermic material, it is removed. Okay, and another plate, what we call it as adiabatic plate is placed. So what is that adiabatic plate in the sense, now even if you bring a hot body close to that adiabatic plate, what happens, will not no heat is supplied to the gas or no heat is rejected from the gas. So we'll remove this diathermic plate, we'll add the adiabatic plate. So now initially the heat is supplied during isothermal expansion. So now during this process, what happens, no heat is supplied or rejected. So whatever the energy that it has, so that same energy is used again to push the piston further. Okay, so whatever the piston is moved during isothermal process, same whatever the energy that the the gas has, so that same energy is again used to push the piston a little more further. Okay, so that we call it as an adiabatic expansion. Means during this expansion, no heat is added, no heat is rejected from the gas. So the expansion takes place due to the energy that he, or what we call it as internal energy that it had during the first process, or whatever the internal energy that it has absorbed during the first process. Clear, guys? Okay, so that this second process we call it as adiabatic expansion. Okay, expansion is taking place, but there is no heat transfer. So again, you can see here the pressure reduces further, and again the volume increases. So next, the third we call it as isothermal compression. So what we'll do is, again we'll remove the third process, that is isothermal compression. So here what we'll do is, we'll remove the adiabatic plate, we'll again add this diathermic plate. So once we add this, again what I'll do, so now I'll bring this cold body, or what we call it as sink, towards this plate. So what happens is, this sink, what it does, it starts absorbing all the heat, whatever the heat it had during these first two processes. So it now starts absorbing it. So when it starts absorbing, what happens, it loses its energy, and what happens, the piston starts coming from right to left. Okay, so that it can be plotted in from the process 3 to 4. So this 3 to 4 process we call it as isothermal compression. Okay, so heat is removed from this gas. So what happens, the piston starts compressing the gas. So during this process 3 to 4, you can see the pressure starts increasing and the volume starts reducing. Okay, the pressure increases and volume reduces. And after this, the fourth one, what we call it as the fourth process, that is 4 to 1 adiabatic compression process. So now this diathermic plate is removed, again adiabatic plate is added. So after this, what happens, even if you bring closer to the cold body or hot body closer to that, no heat is added or no heat is removed. So whatever earlier the heat was removed, so again that whatever heat was removed earlier during this third process, so again now what happens, the piston is again moved further, or piston again compresses the gas, because here you cannot add heat or you cannot reject heat. So what happens is, the piston again further starts compressing the gas. So that is what plotted in the PV diagram, that is process 4 to 1. So during this process, again the pressure increases, okay, and the volume decreases, and finally it attains its initial state. Okay, so we say that a cycle has been completed. So there are two different types of process happening, that is isothermal expansion and compression, and adiabatic expansion and compression, and these all processes are combined, we'll get a what we call it as thermodynamic cycle. Okay, and then finally, once the piston finally it has compressed, so whatever the gas is there, it has attained its initial state. So simultaneously you can see here, during process 1 to 2, the temperature remains same, it doesn't change, only the entropy changes. So during 2 to 3, what happens, the temperature decreases. Again from 3 to 4, the temperature remains same, only the entropy decreases. And finally from 4 to 1, okay, whenever you compress the gas, what happens, its pressure as well as its temperature increases. That's why what happens, from 4, it again the temperature starts increases and finally attains its initial state. So this is your Carnot cycle. Okay, so in this hot body and cold body is used, so that heat is supplied and heat is rejected during the various process. Okay guys, so let's go to the second type of cycle, that is what we call it as an Otto cycle, and also it is named as constant volume cycle. Why? Because the heat is added during constant volume process. Okay, we'll see that what is that. So here again graph is plotted. Okay, so this, the first one is PV diagram, the second one is TS diagram. So we'll go to the processes one by one. So first the process is what we call it as 1 to 2, that is adiabatic compression. So during this adiabatic compression, what happens is, so now initially the air is supplied to the engine cylinder, okay, in piston and cylinder arrangement. So now once the air is supplied, what happens, the piston is moved from bottom to top, okay, or from right to left, so that the air is compressed. Okay, so during this compression, what happens, no heat is added or no heat is rejected. That's why we call it as an adiabatic compression process. Okay, so compression is taking place, but no heat is added, no heat is rejected. So during this process, what happens, the pressure increases and the volume decreases. Okay, so when you compress anything, its volume decreases, its pressure goes on increasing. So once the process has or what we call it as the gas or the system has attended state 2, okay, so the second process starts. So what is the process 2 to 3? We call it as heat addition at constant volume. Okay, so in this Otto cycle, the heat is added during constant volume process, means the volume of the gas remains constant, during that the heat is added. That's why we call it as constant volume process. So heat addition at constant volume. So now what happened? The air, whatever the air is there or whatever the gas is there, it has been compressed. So now the heat is added. So during this heat addition, whatever the volume was there, the compressed volume at point 2, that volume remains same. It doesn't change. Only the heat is added. So what happens when you add heat to it? What happens? Its pressure goes on increasing. Its volume remains same. Its pressure only increases and it reaches at point 3. So you can see here from the diagram. At point 3, 3 is the highest pressure, and at point 1, it has the lowest pressure. Same way on TS diagram, 1 has the lowest temperature and 3 has the highest temperature. Here, so after this third, the heat is been supplied. So once the heat is supplied to the gas, what happens? Eventually, the nature is that once you supply heat to a gas, what happens? It starts expanding. So third one, we call it as adiabatic expansion process. Okay, so the heat is supplied to it. So due to what? The heat supplied to the gas, the energy whatever it is absorbed, so it starts expanding and it releases the energy to the piston. So piston starts moving downwards or to the right side. So during this adiabatic expansion process, the expansion takes place. So during this, no heat is added or rejected. So what happens here is your pressure, it starts again decreasing. Okay, pressure start decreasing and volume starts increasing. Same way on the right side you can see TS diagram. Its temperature reduces. So whenever there is expansion, its volume increases, pressure and temperature decreases, and finally it attains the state 4. Okay, so now adiabatic expansion has finished. Okay, so whatever the temperature is there, it decreases, that the pressure has decreased and volume has increased. Now the fourth one, what we call it as heat rejection process. Okay, so whatever the heat is there, that is rejected out of the gas. But how it is happened? It is happened when the volume of the gas remains constant. Okay, the heat is rejected from the gas when its volume is constant. So same way here, from 4 to 1, okay, it is what we call it as heat rejection at constant volume. So during this process, the heat rejected from the gas and its volume remains same, means it doesn't change. So during this process, what happens is the pressure further decreases but volume remains same way its temperature decreases, and finally its pressure, temperature and volume attains the initial state. So whatever the air was there earlier at state 1, so finally it has attended its initial state. So now we have seen that the initial state and final state are same. So hence we call it as a thermodynamic cycle. So this cycle, one cycle has been completed. So same way again, using the same way, the second cycle is completed and continuously these cycles go on repeating to obtain a operation, final operation. So this Otto cycle you can exactly resembles to what we call it as your petrol engine. Okay, in petrol engine also, based on this process only your petrol engine works. Okay, so once the air and air fuel mixture comes in, after that the compression takes place, that is nothing but your adiabatic compression. After that the heat is added, means the combustion of the air fuel mixture takes place. During that, what happens? Your air fuel mixture remains constant, it doesn't change. That is what your heat addition during at constant volume, that is 2 to 3 process. And once the heat is added, what happens? It starts expanding. Okay, once the explosion of that air fuel mixture takes place, that energy is supplied to the piston and it starts expanding. So that is what, nothing but your 3 to 4 process, and finally whatever the heat is there out of that combustion, it is excited out. So that is nothing but your 4 to 1 process. Clear? So this Otto cycle is what exactly resembled to your petrol engine. Clear, guys? So in next video we'll see another two types of process, that is diesel cycle and dual cycle. Thank you.